Your FastMCP client needs to authenticate. But what if you could handle the entire OAuth flow with just one parameter? We'll build a client that works with any OAuth provider your server supports, from the initial browser login to making authenticated tool calls. You'll see how the same pattern handles token caching automatically, while still allowing for production-grade customization when needed.
From FastMCP import client, import Asyncio. Async def main. Hash the client will automatically handle WorkOS OAuth. Async with client, http://localhost 8000/mcp, auth equals OAuth as client. Hash first-time connection will open WorkOS login in your browser. Print authenticated with WorkOS. Hash test the protected tool. Result equals await client, call tool, protected tool, message, hello. Print result. If name equals main. Asyncio, run main.
This demonstrates the OAuth proxy pattern with provider-agnostic client authentication. The code shows how client applications can delegate authentication entirely to a server-configured OAuth provider without handling credentials or token management directly. The distinctive aspect is that the same client code works seamlessly with any OAuth provider, GitHub, Auth0, WorkOS, etc., configured on the server side. The pattern works through a clean separation where the client only specifies it wants OAuth protection via the auth equals OAuth parameter, while all provider-specific details are handled server-side. The client automatically manages the browser-based login flow, token caching between sessions, and token refreshes, while the server maintains the actual OAuth configuration and provider integration. This design keeps client code identical regardless of which authentication provider the server uses. This approach matters because it eliminates the need for clients to implement provider-specific authentication logic, significantly reducing code complexity and maintenance. The trade-off is that servers require proper configuration of the chosen OAuth provider and must handle token storage securely, especially in production where additional settings like JWT signing keys and persistent storage become necessary. The pattern excels in distributed systems where you want consistent client behavior across different authentication providers. Let's break it down line by line.
From FastMCP import client.
Imports the client class from FastMCP, your primary interface for MCP server connections. This abstracts all protocol handling, authentication flows, and request serialization, while the actual OAuth provider, GitHub, Auth0, WorkOS, etc., is configured server-side. The same client code works regardless of which provider the server uses.
Import Asyncio.
Imports Python's built-in Asyncio library to enable asynchronous operations. This allows non-blocking network calls to the MCP server, which is required for the OAuth authentication flow and subsequent tool execution. The same pattern works regardless of which OAuth provider the server uses, as the provider-specific configuration happens server-side.
Async def main.
Defines the async entry point for OAuth-protected MCP operations. The async def is required because FastMCP's client uses async I/O for network calls, and this pattern ensures proper event loop integration. All OAuth provider interactions, GitHub, Auth0, WorkOS, etc., flow through this same async interface, with the actual provider configured server-side.
Hash the client will automatically handle WorkOS OAuth. Async with client, http://localhost 8000/mcp, auth equals OAuth as client.
This establishes an OAuth-connected client using FastMCP's context manager pattern. The auth equals OAuth parameter triggers automatic browser-based authentication flow, working consistently across all supported providers, GitHub, Auth0, WorkOS, etc., as configured server-side. The context manager ensures proper connection cleanup, while the client handles token caching and renewal transparently.
Hash first-time connection will open WorkOS login in your browser. Print authenticated with WorkOS.
This print statement confirms successful OAuth authentication with the configured provider. The first-time connection triggers a browser-based login flow that works identically across all supported OAuth providers, with the actual provider determined by server-side configuration. It serves as a simple verification that the client has obtained valid credentials before making protected tool calls.
Hash test the protected tool. Result equals await client, call tool, protected tool, message, hello.
This invokes the protected server-side tool named protected tool with a structured input payload. The await handles the asynchronous RPC call through the authenticated connection, returning the tool's response. The client uses provider-agnostic OAuth, the actual authentication service. GitHub, Auth0, WorkOS, etc., is configured server-side. This same pattern works regardless of which OAuth provider the FastMCP server uses, with the browser flow and token caching behavior remaining consistent across all supported providers.
Print result.
Outputs the result from the protected tool call to the console. This verification step confirms the OAuth flow completed successfully and the tool executed with proper permissions, regardless of which provider, GitHub, Auth0, WorkOS, etc., the server actually uses. The same client pattern works universally across all FastMCP-supported OAuth providers.
If name equals main.
Python's standard entry point guard prevents the async event loop from executing when this module is imported, ensuring the OAuth flow and tool calls only run during direct script execution. Critical for both development and production to avoid unintended authentication attempts.
Asyncio, run main.
Boots the async event loop and executes the main coroutine. This is the standard entry point pattern for async scripts, required because Python won't automatically run async functions at the top level. The asyncio, run, call handles event loop creation, execution, and cleanup in one line. FastMCP OAuth client pattern. This async client demonstrates FastMCP's provider-agnostic OAuth flow handling, where auth equals OAuth triggers automatic browser-based authentication regardless of whether the server uses GitHub, Auth0, WorkOS, or other supported providers. The actual OAuth provider and its specific configuration are determined server-side, while the client maintains identical behavior across all providers. Production deployments typically require additional server configuration like JWT signing key and persistent token storage, though the client pattern remains unchanged.
The connection that knows no provider speaks every protocol